All right, so we're going to do some practice problems now with arcs and chords. These can be tricky because a lot of the problems, not the first one obviously, but a lot of these problems don't give you a visual. They don't give you a picture with it, so you have to draw the circle and figure out where to place everything. So let's look at the first one here. We'll do just a few together. So first one says find x, y. So that is this whole chord right here. All right, so we're given that this line right here is perpendicular to it. Now this looks like it goes along with theorem 2, looking at my notes here. It says if a diameter of a circle is perpendicular to a chord, now this is not an entire diameter, but it is part of an entire diameter. It goes from the center and it's perpendicular to a chord, so that still counts. Then it says the diameter bisects the chord, so I know those parts are congruent. So I could, looking at this triangle over here, do a little Pythagorean Theorem action, find that side, and then I could double it and get the whole thing. So we could quickly do that. We do 5 squared plus, you could call this b if you want, b squared equals 13 squared. Go ahead and do that math. Looks like you end up with b squared will give you 144, so b equals 12. Take the square root. Okay, so then we want to find all of xy, so b is 12, so we could double it. Xy would have to equal 24. Not too bad. Let's take a look at one of those ones where you'll have to draw the picture yourself, like number 4, for instance. So I already drew the circle. I use a little compass to help me out because I'm not very good at drawing circles. So, okay, let's read through it. It says, suppose a chord is 20 inches long and is 24 inches from the center of the circle. Find the length of the radius. All right, so they're talking about a few different things. They're talking about a chord, so we'll have to draw that. Let's see, it's 24 inches from the center, so that's the distance from the center of the circle. And it's also talking about a radius. So there's a lot of different chords I could draw, lots of different radiuses or radii. But I know that triangles help me a lot with these problems. So I'm going to somehow, with this information, try to draw a triangle. Now, it talks about a chord, 20 inches long. I have no idea where this chord is, so I'm going to draw it anywhere. Okay, I'm just going to pick a spot. So I'll start it here, and I'll draw a chord like so. Okay, and I know that whole length is 20 inches. All right, so it tells us this chord is 24 inches from the center. So let's make a center point. And I know it's talking about the distance from the center is 24 inches. So I know that is the perpendicular line I can draw from the center. Okay, boom. And one of the theorems we just looked at says if it's perpendicular, right, if it's on a diameter, which this would be because it's going through the center and it's perpendicular, then it bisects the chord. So that chord's 20 inches long, so I could label these as 10 and 10. All right, cool. And also they did tell us this distance is 24. All right, now it says find the length of the radius. Now I don't have a radius drawn. A radius would go from the center and it would just go to any part of the side here of the circle. Now, again, I want to make a triangle because I know that that's going to help me most. Like if I drew a radius out here, I'm not going to be able to find that thing. That's not going to help me. So I'm going to draw it either this way or this way. Just pick one. Doesn't matter. There's my radius from the center to the side of the circle. So now I just need to find this guy. I could call it R for radius. That works. And you're just doing a little Pythagorean theorem. So half the battle with this problem was just getting a good picture drawn and getting the whole problem set up. So we're doing 24 squared plus 10 squared equals R squared. Okay, type that in your calculator, simplify it. You end up getting that radius equals the square root of 676. Go ahead and simplify that. That is a perfect square if you type it in your calculator. So our radius is a whole number, and it's 26. Oops, we should put inches. It did give us a unit of measurement, so we should include that. All right, let's take a look at another one. Circled a few of these. Let's look at number 6. All right, number 6, go ahead and draw a circle. I already did. So it says, suppose the diameter of a circle is 30 centimeters long. So I'm going to go ahead and just draw myself the diameter. Again, I don't know where it's going to be. I'm just going to draw it straight across. Okay, diameter is 30 centimeters. I'm going to go ahead and label my radius then. This would be 15. And it says a chord is 24 centimeters long. Find the distance between the chord and the center of the circle. All right, so the chord, I have no idea where the chord is. I've done plenty of problems like this, so I know, but you can do by trial and error. Try to draw a chord somewhere and see if you can get some triangle going on. I'm going to actually draw my chord with one end point here and just draw it straight across somewhere else, like that, for instance, because I can see how I could create a triangle this way. Now let's see, they tell us, what else do they tell us? The chord is 24 centimeters long. We want to find the distance between this chord and the center of the circle. So let's draw the distance. Remember, that's just the perpendicular line that you can draw from the center to the chord. So 90 degrees. And by one of our theorems that we just looked at, this distance right here is on a diameter, right? Which means if it's perpendicular to it, it bisects the chord. So I can mark those congruent. So this chord that we said was 24 centimeters long, I can label this part, it's kind of small, but I could label that 12 and this 12. All right, and what do we want to find? Find the distance between them. So from here to here. So you can give that a variable, you can call it whatever you want, we'll call it x. And we're just doing Pythagorean Theorem again here. So you would do x squared plus 12 squared equals 15 squared. Let you guys solve that. You do get another whole number though. X equals 9. So that would be length 9 centimeters. Let's maybe look at one more. Flip it over. There we go. Let's take a look at number 10. All right, so there's no words here, just a picture, and they want us to find something. This didn't print off on my paper, but it should say, find the measure of arc NP. Okay, so let's locate that. Arc NP is right here. The measure of the arc is going to be a degree measurement. It's not the length of the arc, it's the measure of it. So we should have a degree in the end. Okay, so I have a chord here, and it's marked congruent to another chord here and another one here. What that shows me is that the arcs, this is based on theorem number 1, if you want to look back at your notes, but that just means that these arcs are all congruent as well. Okay, so they do give us part of the degree measurement here of the circle. They tell us this part is 120 degrees. So I could take the measure of all of it, 360, subtract off that part I know, 120 degrees, which would give me 240 degrees. So there's 240 left remaining between the rest of this, all three of these, and we know they're all congruent. So if I just take 240, divide by 3, I get 80 degrees for each one. And it wanted just the measure of arc NP, so 80 degrees. There you go. You guys try the rest.